gravitational waves are really interesting. They're allowing us to find objects that we would never be able to see otherwise. Now, we've been able to see pairs of neutron stars going around each other. If one of them at least is a radio pulsar, and we can see that, then we can identify these, and we had some idea of this category of objects. But we gain additional information from watching these spiral in and merge. And then binary black holes, we could not measure these at all beforehand. This is an entirely new thing. So this is, it's really exciting. So obviously with the gravitational waves, first off, you get to prove the general theory of relativity correct in saying that there should be gravitational waves. And then we get to also learn all kinds of interesting astrophysical things about these things. What are these systems that are merging? What kind of masses do they have? How are they spinning? All this kind of stuff. In particular, when you talk about the neutron stars merging, there's additional information you know. The black holes you can treat as point sources so that they don't have any extent to them. So the calculation of their in-spiral is fairly straightforward. It just depends on their masses and spins. Whereas with the neutron stars, these have some extent to them. And so if they are getting quite close to one another, there's tidal forces that kind of distort them. And that leads to some additional transfer of angular momentum between them that affects the in-spiral in ways that could be detected with future observations. So what we could do is we could actually measure just how big the neutron stars are in addition to their masses. And so that would tell us about their densities, and that would help us understand what neutron stars are made out of. So that's a really exciting thing that should be coming out of these gravitational wave measurements in the near future.